Live from the BBC, The Naked Scientists.
Coming up this week, we're taking your science questions on anything, because it is The Naked Scientists Science Q&A. Hello, I'm Chris Smith, and for the next hour here on The Naked Scientists, it's very much your game. You just call in 08459 25 2000 or email me chris@nakedscientist.com and we'll answer any science question that you'd like us to talk about. Get calling now, 08459 25 2000. Any question goes. Also, with a rundown of what else we have to look forward to us on tonight's programme, here's Dave Ansell and Phil Rosenberg. Phil.
OK, well, for me, we're going to be hearing about the first results from the Stardust mission that went to a comet, Wild 2, and brought back samples.
And on Kitchen Science today, we'll be finding out about music and how your brain understands sounds and language. Things like this. So if you want to find out what that's like, or if you have any ideas, give us a call on 08459 25 2000. And if you want to find out, listen on to the show.
There is an Encyclopaedia Britannica up for grabs if you can guess what that was saying. We'll be playing it again lots and lots of times during the programme, and we'll be finding out what it actually means, all about the science of music in Kitchen Science with Anna Lacey later on this evening. But don't forget, if you have any science questions, 08459 25 2000 or email chris@nakedscientist.com. Now's the time to call.
The Naked Scientist Podcast, brought to you by thenakedscientist.com.
Now, it's been a really exciting week this week for looking for life, and in fact looking for some of the earliest signs of life that have ever been found on Earth, because a group of scientists in Japan, led by a guy called Yuichiro Ueno from the Tokyo Institute of Technology, have found the earliest signs of life here on planet Earth, and it dates back, guess how long, 3.5 billion years. And in fact, these early organisms were what are called methanogens, in other words, bacteria that make methane. How they actually did the experiment was they went to a part of Australia, in the west of Australia, called the Dresser Formation. And this is very primitive rocks dating back at least 3.5 billion years. And they consist of some lava, which has got some intrusions or some rifts in it filled with quartz. And that's overlaid by sedimentary rocks. And when they zoomed in on those quartz crystals, they found they contained tiny inclusions, in other words, little bubbles. And these bubbles have turned out to be microscopic time capsules, because when the researchers crushed up the quartz, they found that the bubbles contained traces of very, very ancient water, some carbon dioxide, and methane. And when they analysed the chemical composition of that methane, they found that it had the hallmark of life. In other words, the isotopes, certain forms of the same chemical, which it contained, were very much specific to the kinds of isotopes you would see produced by life, because life favours very light isotopes. And so this methane was produced by very early microbes. And why they think this is so important is that 3.5 billion years ago, the sun was much younger than it is today. And that meant that it was a lot less warm. So it was pumping out a lot less heat. And a greenhouse gas like methane could therefore have been very useful to the early Earth to enable it to warm up enough to sustain and support other forms of life. So a wonderful discovery, and very interesting, because while scientists knew that life probably was beginning to get going at that time in Earth's history, we didn't know what sort of life it was. Fantastic finding. Dave?
Well, now, aeronautical engineers for years have been wanting to be able to, instead of using flaps to control aeroplanes, be able to bend the wings and the surfaces so all the air moves just gently across them. Now, engineers in MIT in America have worked out a cunning way to do this. They noticed that lithium polymer batteries, when you charge them up, they kind of change shape and bend. So they thought,
what, the kind of cell you find in your phone?
Yes, the very expensive ones you find in some phones. They discovered that they tend to bend when you charge them up. So what they've worked out, if you can make planes' wings out of a special kind of rechargeable battery, when you charge them up, they'll bend, and so you can alter the direction of the air, and it works beautifully.
Is this just, though, at the tiny scale, the size of a battery? What happens when you scale it up to the size of a Boeing, though, Dave?
Well, they haven't done it yet, but they think it should just work just as normal, as it does already.
Is it actually better than doing it the manual way?
Well, it's not so much doing the manual way. It's if you use a flap, you get a sort of sharp corner on at the back of the wing. And that means all the air kind of gets all turbulent and swirly, and that wastes loads of energy. So
it's less efficient. So this is a way of making a much more efficient plane wing.
And much better manoeuvrability on fighters and things like that.
Exciting. Phil?
OK, well, you were talking earlier about 3.5 billion years ago, the start of life on Earth. I'm going to be going back an extra billion years to the beginning of the solar system.
I'll see your 3.5 billion years and raise you a billion years.
Absolutely.
Go on then.
So I'm going to be talking about comets. Now, the Stardust mission just got back this year from Comet Wild 2. It actually went out to this comet and flew through the cometary tail and actually picked up little particles that were actually inside the comet that then got blown out into the cometary tail. Now, once it had collected all these particles, closed up its containers and came back to Earth, so we could actually get the samples on Earth and analyse them in the lab. Now, that's the first ever sampling of a comet, and actually it's the first sample we've got from anywhere else since the moon landing, so for a long time now we've not had anything from outer space.
What do these samples actually show, though, Phil, and why are they important to science?
Well, what we found in these samples, we expected to find lots of stuff that was essentially cold. Comets were formed way out in the far reaches of the solar system, where it's really, really cold, about minus 230 degrees. And we thought they'd be made up of dust and some ice particles, ice grains. Now, what we actually found when we got this stuff back, was that they had lots of olivine grains in, which are actually formed at really, really high temperatures, so hundreds of degrees, thousands of degrees.
What actually is olivine?
Olivine is actually a mineral. You can find it on Earth, actually. And in fact, it's one of the minerals responsible for creating the green sand you get on some Hawaiian beaches. It's sort of a green mineral formed at high temperatures.
But the significance of the fact that it only forms at very high temperatures, and this comet's come from somewhere that's pretty chilly.
Exactly. So what we think is happening is that the olivine grains are formed right up close to the sun, where it's really, really hot. And then there's some sort of process that blows these grains out into the far reaches of the solar system, where they can get caught up in these cometary nuclei that form out there and then get transported in as comets. And this is what we think's going on. But it really shows that we're not quite sure what's going on with the early solar system. The theories are still evolving, and really shows it was quite a interesting place to be. You know, all sorts of things were going on, things were getting blown around, mixed up. And really it was, quite a fascinating process.
But it's quite hard to measure the early solar system because, of course, we've only got our own one close enough to look at, and we're already 4.5 billion years down the track, so it's quite hard to wind the clock back and see exactly what's going on and what makes a solar system, isn't it?
Absolutely, and that's why comets are so interesting, because they've been sat out at minus 230 degrees C in deep freeze, essentially, in the far reaches of the solar system, until eventually another comet comes close by, gives it a nudge, and knocks it in towards us, and that's when we see it as a comet with the big cometary tail. So these things have been in deep freeze for, 4.5 billion years so far, and by analysing those, we can actually get an idea what was going on right when the solar system was first being created.
It's the Naked Scientist Science Question and Answer Show this week, and if you want to have a question answered this evening, 08459 25 2000, or you can email me, chris@nakedscientist.com. Right, now let's go over to King's School in Ely, where Anna Lacey is with Matt and Emily, and we're going to find out about the science of sound. Anna.
Welcome to the King's School in Ely, where this week we're going to be astounding you with sound and finding out all the glorious, glorious things about the science behind music. And here to help us do that this week, we've got our amazing science guru, Wendy. So, can you introduce yourself?
Yeah, I'm Wendy Sadler. I'm from Science Made Simple, and we take loads of science stuff around to schools and try and make it fun and really exciting.
What is it that we're exactly going to be doing today?
Well, today we're going to be testing out people's sort of listening skills, and we're going to see how good they are at spotting some words within a sort of electronic voice.
Wow, OK, that sounds pretty intriguing. Well, also here with us, we've got some student helpers. So, can you tell us your name and your ages, please?
Hi, I'm Emily and I'm 10 years old.
And what about you, sir?
Hi, I'm Matthew and I'm 9 years old.
And so, Matt, what's your favourite thing about science?
It's probably the experiments. I quite like doing the experiments.
And obviously, most importantly, do you know anything about the science behind music, Emily?
No.
That's a good job, because that is exactly what we're here to do, to tell you today. So, what exactly is it we're actually going to be doing, Wendy?
Well, we're going to do a fun experiment that's kind of about science and sound, and also about how our brains work a little bit. So we're going to play a clip in a moment, which is a very early attempt of a computer trying to speak. So it's a computer synthesising a human voice, okay? And the human voice is a very complicated sound. So it's quite hard to work out what it's saying. So this is the challenge for everyone, really, to listen to this sound clip and see if they can work out what the voice is saying.
So people at home, you should be listening very, very carefully to what Wendy's going to play you here. You need absolutely no equipment whatsoever, so there's no excuses this week. So Wendy's going to play this song for us now, and I want you guys, Matt and Emily, to try and tell us what you think it says.
Here we go.
OK, any ideas, guys, what that said at all?
No.
And what about you, Matt?
I haven't got a clue.
OK, can we hear it again, Wendy? This time we'll try and listen
of course.
again a bit more carefully.
Here we go.
So, I mean, were there even any words that you could pick out there, Emily?
Absolutely none. I think I heard sound at one point.
Oh, okay, so we've got a bit of a hypothesis there. Well, okay, well, we're not actually going to tell you exactly what it says quite yet, because we want you people at home to have a think about what it said there, and we'll be playing it later on again in the show. And we want you to phone in and tell us what you think they said. So, if you've got any ideas, then you can get in touch with us. You can call 08459 25 2000, or you can email chris@thenakedscientist.com, and if you are correct, then you may well win a prize. So, okay, well, thanks for Wendy, thanks for Matt and Emily, and we'll be going straight back to the studio now.
Thanks, Anna. Do you want to have a quick one more listen to that, if you think you know what it is? What are they saying? If you can work it out, 08459 25 2000, or email chris@nakedscientist.com.
The Naked Scientists. Supported by the Wellcome Trust.
It is The Naked Scientists, and here with us on this week's show, Dave Ansell and Phil Rosenberg and me, Chris Smith. Got an email here from Lon Chubitz, who is, I think, in the US. He says, greetings from the University of Illinois in Champaign-Urbana. I'm a graduate student in chemical and biomolecular engineering, and I love your show. In fact, many of us here are hooked on The Naked Scientists in our lab, and being a scientist myself, it's encouraging to hear a show that gets current, relevant topics out to the general public in a fun and easy-to-understand manner. And also, you guys manage to get excellent guests and keep them lively, even if their topics can get a bit dry. You're all brilliant. Keep up the good work. Well, thanks very much for that. It's very kind of you, Lon.
We've got another email here from Ati El Bakush. He doesn't say where he's from, but I hope you're listening. He says, thanks for the great show. It's tied in first place for one of my favourite podcasts. Since discovering your treasure trove of archived podcasts, I've been saved from having to endure the psychological torture, which is local radio or total silence, which is actually his preference, total silence. Well, fair enough then. I've even dumped a few shows onto my phone so I can listen to them when I'm out and about on foot.
Now, that's dedication for you.
Absolutely.
If you want to drop us a line at The Naked Scientist, chris@nakedscientist.com, and also you can drop us a line by phone. It's 08459 25 2000. Gordon is in Suffolk. Hello, Gordon.
Hello there.
Thank you for joining us on The Naked Scientist. What would you like to talk about?
Well, I'd like to talk about water. And with the ever-increasing shortage of water in reservoirs and underground storages, why can't we purify seawater to overcome the problem? And I understand that they're already doing that in Jeddah.
We can, basically. The problem is it uses loads and loads of energy. There's two ways of doing it. You can either boil up the water and then recondense it. So you turn it into steam, then recondense it into water. Obviously, that's going to use loads and loads of energy. You know how expensive it is to boil water in a kettle. Mm-hmm. And the other way of doing it is something called reverse osmosis, which is basically taking a really, 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 really fine filter and pushing the water through it, and the salt stays the other side. But this is a load more efficient than boiling it, but it's still really expensive in energy. And considering the fact that the greenhouse effect is a big problem because we're using too much energy already, if we started producing all our water by desalination in one way or another, we'll be really in trouble.
So it's better to just live sustainably, I guess, isn't it? Does that clear that one up, Gordon?
Yeah, it does, yeah. I'm surprised in a way that, you say it's so expensive. I would have thought there'd have been a way round it, really. But
well, the thing is that there's no such thing, energetically speaking, as a free lunch. No. And what you're trying to do is to take salt water, which has a great concentration of minerals in it, and separate those minerals into a strong concentration of minerals and a strong concentration of water, in other words, pure water. Mm. So in other words, you've got to do work to literally sort the wheat from the chaff. There's no such thing as a free lunch in energy terms, and that work comes at a high price. If we do it, we have to burn a fossil fuel in some way or another to do it. The sun does that almost all the time, all around the Earth, because the sun is hitting the surface of the ocean, it's evaporating some water, just the water goes, the minerals are left behind in the sea, and that's why it gets salty, and the evaporated water goes up, forms clouds, and then as soon as it hits a rising area of land, the clouds are forced to rise, and that forces the water to drop as precipitation. So the sun is doing this for us, but you know how much energy the sun has got to throw away. The sun's got money to burn, let's say. Mm. Do you want to have a go at the quiz, Gordon?
OK, yeah.
Here we go. A dodecahedron has 12 faces. Do you think that's science fact or science fiction?
No, I think that's fiction.
Sorry, it was actually true. It's a 12-sided solid is a dodecahedron.
Right.
Do you want another go, Gordon, just to see if you can get one right?
OK.
All right, then.
Right.
James Napier invented the hot air balloon. Is that science fact or science fiction?
I think he did invent it.
I'm afraid not. It was the Montgolfier brothers who invented ballooning. Napier invented logarithms.
Right.
Well done, Gordon, anyway. You had a great question. We really enjoyed having you on the show.
Much.
Thank you for calling up.
Bye.
The Naked Scientists, Chris, Dave and Phil. We're taking your science questions this evening, and if you'd like to get on the programme, 08459 25 2000 is our phone number, or of course you can email me, chris@nakedscientist.com. Now, every week on the show we have a podcast pick. In other words, we invite you to tell us about your interesting science that's going on wherever you are, and we're in the middle of a short series from the European Space Agency. In fact, there's a mission called Venus Express, which is going to meet our near-planetary neighbour, Venus, and already in the series we've heard how Venus has a runaway greenhouse effect, which could tell us about what could be coming to Earth, and also we want to find out if there's active volcanoes going on the surface. Well, this week, in part 3, we're going to be catching up with Chris Capella about ESA's worldwide network of ground tracking stations. Here's Daniel Skuka, who brings this report from ESA.
Venus Express is a fantastically advanced spacecraft, and in April will enter orbit around Venus with 7 sensitive instruments to gather a wealth of data. But that data has to be transmitted to Earth, and throughout the mission, telecommands and instructions must be radioed up from the ground. This is where the European Space Agency's worldwide ESA tracking ground station network comes into action. ESA maintains 8 stations in the S-Track network, located in Spain, Belgium, Sweden, South America, and Australia. Earlier this week, Chris Capel, Venus Express Operations Manager, was in the main control room at ESOC, ESA's Space Operations Center in Germany, participating in an intensive simulation exercise.
The stations are controlled locally from ESOC, so we do remote control of the stations, except for critical operations like the Venus orbit insertion.
The S-Track system comprises 6 stations having smaller 15-meter antennas and 2 deep space stations with giant 35-meter antennas. These latter 2 are located in New Norcia, Australia, and Cebreros, Spain. Venus Express is being telecommanded via the 35-meter station in Cebreros, which is the newest station to join S-Track, having been completed in September 2005 on the site of an old NASA Apollo tracking station. The Cebreros ground station communicates with Venus Express at X-band gigahertz radio frequencies.
For Venus Express, we're using 8 gigahertz. It's about 80,000 times more than a normal radio station.
But due to the Earth's rotation, the station can only send telecommands or receive data when Venus Express passes overhead. As a result, the spacecraft gathers data in a store and dump mode, storing precious science results on board in a 12 gigabit memory array until it can contact Cebreros for download. During the upcoming and risky Venus Express orbit insertion, the spacecraft will be 125 million kilometers from Earth, and it will take radio signals traveling from Cebreros at the speed of light 6 minutes and 46 seconds to reach the spacecraft. I asked Chris how many missions ESA is currently controlling from ESOC.
Well, we have 14 satellites flying. We have scientific satellites like XMM, and we have Earth observation satellites, and then we have our deep space satellites like Venus Express, Mars Express, Rosetta, and Smart 1 around the Moon.
During next month's orbit insertion, the X-band antenna on the spacecraft will not be facing Earth. Only the smaller and weaker S-band antenna will. So ESA has asked NASA to help out.
They have 70-meter dishes, and for some deep space missions we are requesting their support, just to get some additional coverage or communication with the satellite.
Join us again next week for a report direct from ESOC's main control room when we speak with a veteran ESA flight director on the high-tech drama that takes place here during launches, orbital maneuvers, and landings. For the European Space Agency, I'm Daniel Skuka, reporting from the European Space Operations Center in Darmstadt, Germany.
Daniel Skuka reporting there. And next week we'll be catching up with the final part of what's going on with the Venus Express mission to Venus to find out about the planet's runaway greenhouse effect and active volcanism.
I've got an email here from Tony Nowick in Minneapolis. He apparently on a recent show with Naked Scientists were discussing satellites. Have you any idea how many satellites are currently circling the Earth?
Well, we've obviously got one natural satellite, our moon, so that's one to start with. But we've actually launched somewhere around 8,000 artificial satellites up into orbit around the Earth. But that's not all there is orbiting around there. As well as these 8,000 solid lumps of whole satellite that are up there, we've got lots and lots, probably countless millions of little bits of junk that are up there that are swirling around. Now, that can be anything from a nut and a bolt that's been lost somewhere. There are actually astronaut gloves floating around up there that have been lost during space missions.
I think the International Space Station did actually blow out of the airlock an old Russian spacesuit, which they had rigged up with a radio transmitter, so it became a sort of an orbiting spacesuit, which could be used as a satellite for a little while. And so people on the ground could communicate with it. Amateurs on the ground could communicate with this spacesuit, and it was sending back sort of images and local pictures, and it eventually decayed on its orbit and burned up over the Pacific somewhere.
Fair enough. There's all sorts of stuff out there. But it can actually be quite a problem because a lot of this stuff then, as it's whizzing around at kilometres a second, if it hits another satellite, it can seriously damage it and blow some more bits off. So all the time this stuff is accumulating. There's actually no easy way to go up and remove it. You can't just go up with a vacuum cleaner and slick it all out.
Will it actually decay down and eventually burn up in Earth's atmosphere, Phil, or is it some of it on an orbit which is very stable and it won't go anywhere?
Well, eventually all of it will slowly slow down and fall into the Earth. There's still some atmosphere out there, and all the time it's slowing stuff down, and eventually it circles and spirals in and falls to the Earth. But it's up there for a long period of time, really, and the smaller stuff especially can stay there for a very long time.
Also depends how high you are. The high satellites up in geostationary orbit can stay there for millions of years. The low ones, maybe only a few years.
Absolutely true.
Nigel is on the line. Hello, Nigel.
Hello there.
Thank you for joining us on The Naked Scientist. What would you like to know about?
Well, my wife and I went to see a touring version of Starlight Express recently, and as part of the show we were given 3D glasses to show the special effects.
Yep.
And what I'd like to know is how 3D glasses work, and if you need the 3D glasses to appreciate the effect at the end, how do they produce them in the beginning?
OK. Now, what you have with 3D glasses, you'll have noticed that one was one colour and one was another colour very often. There'll be a red one and a blue one, for example. Did they look like that?
I'd rather thought they were red and green, but certainly two
Sure.
colours.
It's the same principle. There's two different colours. Now, what they do when they project the 3D movie, did you take the glasses off at any point and look at what it looked like without them?
Yes, very, very blurred and nonsensical.
Exactly. Now, what they're doing with the projector, very clever projector, it's in fact one of the most powerful projector bulbs that you have in the world that's used to drive these things. You project two images side by side, one which is very slightly displaced from the other one, and it's displaced by the right amount so that, in other words, you've got two eyes looking at the world, haven't you?
Yes.
And so you're getting two images of the world reaching your brain, and they're slightly overlapping but separated from each other by a small amount, in other words, the distance your eyes are apart. Now, on the screen, what they're doing is projecting these two images, one in one colour and one in a slightly different combination of colours. And what your glasses do is to screen out the colours of one of the images whilst allowing the colours of the other one through. And then when your brain recombines them, it's seeing two different sets of images overlapping each other in just the right way to recreate a three-dimensional image. Would you go along with that, Dave?
Yeah, the way it's basically, if you shut one eye and move your head side to side, the world looks slightly different. The things close to you move more than the things far away, and that's one of the ways your brain judges how far away things are from the two images from your two eyes. And the way they take the films, they just have two film cameras next to each other, maybe 6 inches apart, and from that it can then that will produce exactly the same effect as your two separate eyes.
Because the Victorians had a camera that would make 3D pictures by taking a huge range of pictures over it was a hemisphere arrangement of the cameras, and then you could recombine them to make this incredible three-dimensional image.
It's a very interesting effect because they had some bats, I think they were, that came out of the screen and in effect over your shoulder.
Oh, yes. No, that's absolutely true, because it's fooling you into thinking that you're actually seeing something which is much closer to you than of course, the two-dimensional image being actually projected onto the screen.
And it has to be two colours, does it? Does it matter what the colours are?
It doesn't matter what the colours are, but there's other ways of doing it. All you've got to do is get two different pictures, one to each eye. There's some ways of doing it using two different polarisations of light.
That's right.
And you can use Polaroids, or
so
you can do very fast shutters.
Yeah, fancy sunglasses are the other way to do it, which respond to light going in one direction or the other direction, and you have them at 90 degrees to each other on each different eye, so it screens out the two different images. But your brain does the fooling you. It's your brain that actually is fooling you into thinking you're seeing two things.
Right. And would you get a better picture by sitting in the middle of the projection rather than at the side?
Probably yes. I'd have to think about the geometry carefully, but I think so, yeah.
Quick go at the quiz, Nigel, or are you going to go back to cooking dinner?
So I've got to go back to cooking dinner.
OK, then. Well, thanks for joining us on The Naked Scientist.
Thank you.
Great question. Nigel in Buckinghamshire. If you'd like to join us on The Naked Scientist Science Question and Answer Show this evening, 08459 25 2000 is our phone number, or you can email chris@nakedscientist.com.
Sorting out the sparks from the quarks. The Naked Scientists.
The Naked Scientists, Chris, Dave and Phil, we're here with you this week for about another 35 minutes, and if you'd like to have a go at our competition, remember that we were talking about the science of sound, and we're asking you to try to work out what this is saying. There's a copy of the Encyclopaedia Britannica on DVD in it for you, if you can get it right. 08459 25 2000, or email chris@nakedscientist.com if you have any ideas. And also, give us a call if you have any science questions you'd like to ask. We've got a question from John in Lowestoft. He says, which way does the Earth travel around the Sun, and is the Sun spinning and moving too? Phil?
Yeah, absolutely. The Earth, if you look from above, then it's going round anti-clockwise. Now, obviously, which way is above in the vacuum of space, how do you define that? Well, if you're looking from the North Pole, looking down on the Earth onto the North Pole, then it's going round anti-clockwise. And the Sun's also spinning, actually, as well. It goes round every few hours. And is actually also moving through the galactic disk or around the galactic centre. And so everything's moving around.
And also, of course, the galaxy is spinning. So our Sun is making a grand tour of the galaxy, I think, every few million years, isn't it? It takes to make a complete loop of the Milky Way.
Absolutely. I think it's about 11 million years for the Sun to go all the way around and back to the same starting point again. And then, of course, the Milky Way is moving through the universe. So everything is moving, and it's all a case of what your perspective is on that.
So, Naked Scientists, if you want to ask us a question, 08459 25 2000. We're coming to Bob in Essex quite soon. Before then, a quick question from Donald, who's in Essex, and he says, what makes the Earth spin, Dave, and will it ever stop?
The Earth has been spinning ever since it was created. It could have been because the Earth was created, the Moon was created in a big collision with the Earth. If the collision was just off-centre, then it would have spun the Earth up really, really fast. And when the Moon was created, it was really close to the Earth. And and the tides have actually slowed the Earth down. In fact, 200 million years ago, there were about 400 days in a year. So the Earth has slowed down in the last couple of 100 million years.
400 days in a year?
400 days in a year.
Because the days must have been a few hours shorter in each case then. Because this is actually a legacy of how all our planets form, though, Phil, isn't it? Because there was originally a big disk of material around the Sun, and everything was spinning, and as it coalesced together and formed planets, the conservation of momentum meant they carried on spinning.
Yeah, absolutely. So it's exactly the same principle as when an ice skater that's spinning pulls her arms in, or his arms in, and spins faster. It's exactly the same principle with planets. There's lots of dust and gas all swirling around, and as it all accumulates together into a planet and pulls itself together, it spins up faster and faster.
If you'd like to ask us a question, it's 08459 25 2000, or you can email me, chris@nakedscientist.com. Bob, hello.
How do you do?
Thank you for joining us on The Naked Scientist. What's your question?
My question is about meteorites hitting the Sun.
Okay.
I mean, we know that meteorites hit the Earth quite well, but the Sun is so many thousands, hundreds of thousands times more mass than the Earth, so consequently I should imagine that it attracts many more meteorites, and I'd like to know if that's been observed and what effects it has caused.
Well, that's actually a really, really good question, but there are a few effects that you need to take into account here. Now, the Earth doesn't get hit by meteorites so much because of its gravity, but it's literally because it's going around the Sun, and the meteorites, or meteors before they hit the Earth, going around the Sun as well, in different directions and at different speeds. So every now and again, you get a crossing of the paths, and one hits the other. So we get a meteorite landing on the Earth.
People are actually looking for them, aren't they, Phil, to see if there is anything that's on collision course with Earth?
Absolutely. And there are a few things that have been near misses, a few that have actually gone past, and we've not noticed they were there at all until someone's, been taking a photograph of the night sky, and suddenly there was a meteor that went past, and actually that could have been...
Is it MN4 2004 supposed to come in 2029 and pass within the orbit of some satellites, isn't it? And is potentially one of the closest near misses Earth's going to have, certainly within the last millennium.
There are a good few that are going to come quite close. We've not found one yet that's actually on a collision course, so we're fairly safe at the moment. But yeah, there are plenty that come close, and certainly the small ones. There are hundreds, if not millions, of tiny, tiny meteorites that hit the Earth all the time.
Quick go at the quiz, Bob?
Yes, I'll have a go, certainly.
A voltmeter measures potential difference. Is that science fact or science fiction?
Fact, I should think.
Yep, you're right. Voltage is a measure of potential difference.
Well done, Bob. Do you want another go? See if you can extend your lead. Cryogenics is the study of language. Is that science fact or science fiction?
I should imagine that's a bit of a fiction. A bit of a cold fiction, too.
If not cold fusion.
Absolutely correct.
Well done, Bob. It's been great having you on the programme.
Thank you very much, and bye-bye.
The Naked Scientists, Chris, Dave and Phil. We're talking anything science this evening. It's the Naked Scientists Science Phone, in which we do roughly every month because we have a huge volume of things we can't always slot into every single programme. Get your calls in, 08459 25 2000 if you'd like to ask us a question, or if you reckon you know what this is saying. What were they saying? At the end of the programme, we'll be giving you the answer, but if you can identify it correctly in the meantime, you could win yourself a copy of the Encyclopaedia Britannica on DVD. Now, every week on The Naked Scientist, we cross the ponds across the Atlantic to America to find out what's going on, courtesy of the American Association for the Advancement of Science. Chelsea Ward and Bob Hershon are there with Science Update, and this week they're going to be telling us about how disabled kids could be better communicating, how cats could be knocking off sea otters, and also getting proteins out of prehistoric things like dinosaurs.
For The Naked Scientist this week, we'll be taking a look at new technologies that are helping disabled children find their voices. But before that, we have a story of particular interest to cat lovers. New research shows that keeping cats indoors instead of out is not only safer for them, it protects other cute fuzzy animals too.
That's right. Cats are killing sea otters in California, but probably not in the way you're thinking. Cats carry a parasite called toxoplasma that they shed in their feces. This according to veterinary scientist Pat Conrad of the University of California at Davis.
When cats defecate, deposit their feces outside, or cat litter is dumped outside, and then it rains, those parasites are washed into rivers and streams, and those ultimately reach the ocean.
There, the parasite causes brain disease in sea otters, killing many of them outright and making others easier prey for sharks. Conrad says sea otters are especially vulnerable because they live near the coast, but other marine mammals such as dolphins and manatees can also get infected. In humans, toxoplasma can be dangerous for pregnant women or people with weak immune systems. Conrad says pet owners can help control this parasite by keeping their cats indoors and bagging all litter.
That's right. I know that many Naked Scientist fans are fond of composting, but I'm sorry to say that kitty litter isn't a good candidate for the compost pile because of these parasites. Our next story is about a scientist who has discovered a new way to get information out of some very old bones.
That's right, old as in prehistoric. You may remember in the movie Jurassic Park, scientists use ancient DNA to bring dinosaurs back to life. Well, biogeochemist Peggy Ostrom from Michigan State University doubts DNA can last that long, but she does think she may be able to find and sequence the next best thing, dinosaur proteins. Her lab has already sequenced one type of protein in bones from a nearly 50,000-year-old horse and a 500,000-year-old muskox.
So that gives us some hope that, we could push back the time limits and for other fossils. So we're working our way back in time.
Proteins from dinosaur bones could tell scientists what dinosaurs ate and what diseases they had, and since proteins contain genetic information, they could also reveal new clues about how dinosaurs evolved.
Thanks, Bob. Autism, Down syndrome, and cerebral palsy are very different disabilities, but one thing they have in common is that they make it harder to communicate through speech. And that can make other things harder, too.
That's right. Kids with speech-impairing disabilities often fall behind in reading, writing, and even social skills later on. But most speech therapy technologies are skewed toward adults. That's why Penn State University communications scientist Janice Light is leading an effort to retool them.
So our work has really looked at trying to develop computer technologies that are more appealing to young children, that are really fun to interact with, and at the same time to develop ones that are extremely easy for the children to understand and use. Our goal is that we would put a computer system in front of a child as young as a year of age or even younger, and that from the moment they first see the computer system, that they would be able to interact with it and use it.
One strategy is to custom tailor the computers to each child's life. To hear the word dog, for example, a child might touch a digital picture of his or her own pet, rather than a stock photo. The new systems have already helped many disabled children learn language at near normal rates.
Well, that's all for this week's Science Update from AAAS, the Science Society. Next week, we'll be learning about a tiny plane that flaps its wings. Until then, back to you, Naked Scientists.
Thank you, Chelsea Ward and Bob Hershon there from Science Update. And if you'd like to know a bit more about what they get up to, it's www.scienceupdate.com. And right now, I've got an email here from Robert Curtis, actually. And Robert says, "Dear Chris, with regard to the show on recycling, which was a couple of weeks ago, the reason your carrier bag in the back of your car disintegrated is because they're now made with starch mixed with HDPE, which is the high-density plastic. The starch degrades quickly when exposed to air, and thus you're left with lots of tiny plastic fragments and that were previously bound together by the starch. It appears that manufacturers are also now able to make CDs and DVDs from starch, which should mean that they aid in their decomposition when they go into the soil. Love the show. Regards from Robert. Right, you're listening to The Naked Scientist. Chris, Dave and Phil, we're here with you for about another 25 minutes. If you'd like to ask us any science questions, it is the Naked Scientist Science phone in this evening, 08459 25 2000, or email chris@nakedscientist.com. And also, if you reckon you can work out what this is saying... There could be a prize in it for you. Get calling now.
Laying the facts bare, The Naked Scientists.
It is The Naked Scientists, Chris, Dave and Phil, and we're taking your science questions this evening. I've got an email here from Chris Wood, who's in Des Moines, in Iowa, USA, and he says, Dear Chris and the rest, I've recently discovered your programme on iTunes, and I've downloaded them all to my iPod. I have to make all-night driving trips this week through Kansas. I did it at night, so I wouldn't actually have to look at Kansas. You all keep me awake and alert and safe during my journey, and I learned things on both treks. Thank you very much. I have a science question that's been bothering me for many years. Whenever you go to replace tyres on your car, you notice that the tread is worn away. Where does all the rubber go? You don't see it piling up on the sides of roads or creating dust anywhere that I know of. I'd really like to know what happens to it when it wears off. Thank you very much. How much do you reckon, or what do you reckon happens to all this rubber, Dave and Phil?
I've just been doing a quick calculation.
Go on then.
If a tyre lasts about 5 years, it's probably a bit long, but anyway, I reckon it comes out about 10,000 tonnes a year in the UK. So that's quite a lot.
It's a fair whack of rubber. I must have had no idea how much it would be, but I mean, I would have thought it would all sort of form maybe a thin layer on the roads that would then eventually wear off itself and just turn to dust.
Quite often, if you touch a tyre, you get covered in that horrible black dust stuff.
Yep. Yeah, it's quite right. Tyres are really bad, in fact, as polluters, because they don't only contain rubber, they've got a lot of heavy metals, and there's a lot of things like cadmium in the rubber. So that's why when people say, let's just burn old tyres, it's really bad, because all the stuff goes up into the atmosphere and then drops out on soil that animals eat. The grass that grows on there, we eat the crops that grow on there, and all these heavy metals can end up back in us, which is why incinerators are actually quite bad news. I've just done a quick back-of-an-envelope calculation here for Christy, and we'll focus on the US, because obviously she's from the US. This says, 300 million people live in the US, according to the latest stats, okay? So let's assume that they've all got 2 cars, okay? Not each of them, per family of 4, okay? Now, a car has got 4 wheels, let's say. We'll assume they're not massive great lorries. So that means that in the US, at any given time, there's probably roughly 600 million tyres in use in any given year. Sound reasonable?
Sounds.
Okay. Now, let's assume that the tread on a rubber tyre is... Let's assume they're quite small tyres. They're 10 centimetres wide, to make the maths easy. 10 centimetres wide. The circumference of the wheel, let's say, is 3 metres. So that's 300 centimetres long. And the thickness of the tread is, say, a centimetre. That means the volume of rubber on a wheel that's wearing out is about 3 litres, or 3,000 centimetres cubed. Yeah? Well, if there's 600 million tyres, then that means there's 3 litres times 6 million tyres, 600 million tyres, okay? So if you convert that to metres cubed, that's a staggering 2 million metres cubed of rubber every single year on the circulation of just in America, okay? Now, the density of rubber, I've looked up, it's 1,200 kilograms, or 1,200 kilograms per metre cubed. So that means there are 2 billion kilograms of rubber in tyres in the US. Okay, so if we assume those tyres last, you said 5, I'm going to say 4 years, because I was just thinking about it. That means that roughly 2 billion kilos of rubber gets lost, worn out, turned into dirt and dust and things every 4 years. So that means that roughly 500,000 tonnes of rubber turns into dust on America's roads every single year. That's a staggering amount, isn't it?
It's a scary amount of rubber.
Okay, let's have a quick chat to Bob. Hello? Sorry, he seems to have gone. Let's have a quick chat to Richard. Hello, Richard.
Hello.
What was your question?
My question is, global warming, reference glaciers, reference if you put a glass of water, fill it up with ice cubes, when it melts it's exactly the same volume, hence the reason when glaciers melt there's absolutely no difference, so global warming, you've got it wrong.
Dave, what do you say to that?
You're right for ice floating on water. It shouldn't change the volume at all. But if you've got ice on Antarctica or on the Greenland ice sheet where it's on rock, nowhere near the sea, when that melts, it's going to end up in the sea and increase the volume of the sea.
Yeah, that's absolutely right. Because quite right, floating ice doesn't change the doesn't actually change the volume of water when it melts because it's displacing an equal amount to itself. But Greenland is a massive ice sheet, and there is tons and tons and tons of water locked up as ice on land on Greenland, which isn't affecting ocean levels. And in fact, the melting of ice on Greenland is raising the ocean depths by about 0.5 centimetre every single year at the moment. And if all that lot goes, within the next 100 years, we could see a 1 metre rise in sea level within the next 100 years. It's quite staggering, isn't it?
Well, to us in Essex, it'd be a serious problem.
It will be, actually. You could. I don't know where you are in Essex there, Richard, but you could be on sea.
I think we will be, yes.
Or even under sea.
We'll be looking at the Thames.
Quick go at the quiz?
Not a clue.
Do you want to have a quick go at fact or fiction?
Yes, please.
OK. Silicon is the second most common element on Earth. Is that science fact or science fiction?
Fiction.
Unfortunately, it's absolutely true. After oxygen, silicon's the most abundant.
OK, you've got to get this next one right, OK?
Go for it.
The Polaroid camera is named after its inventor, Edwin Polar. Do you think that's science fact or science fiction?
Science fact.
I'm afraid not. The Polaroid camera was invented by a guy called Edwin Land, apparently.
Thank you very much.
Thanks for joining us on the programme.
Good night.
It's The Naked Scientists, Chris, Phil and Dave. We're here with you taking your science questions as part of our science phone-in this week. Can you work out what this is saying, though? The answer's coming up very, very shortly. But before then, let me introduce you to Diana Liverman, because every single year in Cambridge they have a series of lectures called the Darwin Lectures, and this year they're on survival. And the final talk in the series this year was by Professor Diana Liverman. She's from Oxford University, and she went talking to Naked Scientist Anna Lacey about why ignoring climate change won't make the problem go away.
Climate change is a very serious threat to the survival of certain ecosystems and certain cultures. And the reason it's a threat is that we now know that climate change is already occurring. We know that it's likely to occur more rapidly and more discontinuously than we think it's going to. And that's going to have serious effects on people, for example, in low-lying coastal areas, for ecosystems that are going to have to change because of higher temperatures.
We've been hearing about things like this for years now, and still we leave our TVs on standby, and still we drive a mile down the road to the shops. How are you going to make people care about this?
Well, it's a very good question. I think our challenge is to sort of get over climate fatigue. People keep hearing about it, and what we've got to do is to say, no, now we know something new. It really is very serious. In terms of what we've got to do about it, I do think that there's a lot that individuals need to do, but I actually think that the government could do a lot more to help individuals respond, because a lot of us might want to do things, insulate our houses, we might want to buy cars with higher mileage per gallon, but we can't afford it, or we would do better if there were some regulations or some incentives to help us respond.
What about changing technologies, new technology like wind farms?
Technology is going to be a very important part of solving the climate change problem. The most obvious set are just things to do with efficiency and conservation. I drove here in a Toyota Prius.
Are these the type of cars that have both electric and petrol?
Yes, and they get pretty good fuel efficiency, but it's actually not their fuel efficiency, it's that they've got the lowest carbon dioxide emissions on the road. But if the government puts in incentives, then that's actually going to drive technological innovation and we'll get to a lower carbon future much faster.
But do you think governments actually believe in changing climate, aside from all the things that they say in Parliament?
The British government, I think, believes in the problem. It's just that the decisions they've got to make, they don't seem to have the courage to make them at the moment. I mean, there's been a lot of things that have been done in the UK, but it's not enough. We've got to get our emissions down by 60% if we're going to stabilise the climate. And at this point, we're barely at about 13 or 14%.
But how on earth are we going to make up that massive gap?
I don't think it's enormously difficult, but people need a little bit of financial help, they need a little bit of convincing in order to make those changes. So what we need is sort of wise government to help us, push us in that direction.
And until the government actually sit up and really make a change, what can people do to help with climate change?
I would turn down your thermostat a couple of degrees, I'd switch all your appliances off standby and get on your bicycle.
On your bike, that was Anna Lacey talking to Professor Diana Liverman, the director of the Environmental Change Institute at Oxford University, about what the average person can do to try and turn down the heat on climate change.
Fancy listening to The Naked Scientists in your bed, on your way to work, or even at work? Why not subscribe to our podcast? For more information, visit nakedscientist.com/podcast.
The Naked Scientists, Chris, Dave and Phil, we're taking your science questions this evening, 08459 25 2000, or email me, chris@nakedscientist.com. Christine, good evening.
Good evening.
Thank you for joining us on The Naked Scientists. What would you like to talk about?
Right, your deep space probes and space shuttles and all that. I wondered how NASA communicated, because I know for a fact, being a radio amateur, that it's very hard to get a signal at any great distance if conditions aren't exactly right. So you must be running a hell of a lot of power and have a lot more equipment, sort of a different sort of variety to what amateurs are allowed to have.
Well,
get a signature or a signal out to these spaceships and get it back, because there must be some kind of time delay as well. So how do you know, or how do you get a signal out quickly when you know there's something wrong?
It's actually requires a lot of power. Like, you're absolutely right. Actually, we use huge, big radio dishes, things like the Arecibo radio dish in South America and the Green Bank radio dish. These huge things are metres across, if not nearly kilometres, some of them. And we use a large number of these to actually communicate with spacecraft. Now, you're right, there is a large time delay, and actually I was involved with the Huygens mission, which was at Saturn, and there was a delay of a few hours there for the data to actually get back to us. Now, because of that, we actually used everything on remote control. Everything was pre-programmed to do exactly what it was going to do, and then it just did it, and then we got all the data afterwards. So we actually had no direct control about what was going on while it was happening.
Oh, right. So you're talking in gigahertz rather than in what we use.
Yeah, absolutely. We're talking huge powers.
I'm just going to usurp your question just 1 second, Christine, because I've got a quick one here. If you could just do this very quickly, Phil, because this is very much your field. It's from Grant, who says, "Hi, Chris, I'm listening to your podcast on the Tokyo subway. With the launching of New Horizons," that's the probe which has just been launched to go to explore the outer reaches of our solar system and to look specifically at Pluto and that kind of area. He says, "This is apparently the fastest spacecraft yet." That's definitely true. "I'm wondering when it will surpass the Voyagers as the farthest spacecraft from Earth." What do you think, Phil?
Well, the easy answer to that, or the quick answer, is never, because the New Horizons spacecraft is actually going to go into orbit around Pluto, so it's going to stop there. It's not going to get any further out. But the Voyager spacecraft are an immense distance away now. They're actually outside our solar system and in interstellar space, so space between the stars. So it would be really hard pressed to actually get something out that far again.
Because when people made recent contact, I think with one of the Pioneers perhaps even, or maybe Voyager, I can't remember which one it was, about 5 years ago, it took a day for the message to come back.
They're a huge distance, and as I say, they're actually outside the sun's magnetic field now, so that floating around in interstellar space, they really are the furthest thing we've ever sent, and probably ever will for quite a long time, I think.
Quick go at the quiz, Christine.
Go on then.
OK, a particle of light is called a photon. Is that science fact or science fiction?
Fact.
Yep, you're right. Einstein got the Nobel Prize in 1905 for discovering that light came in small packets.
And your next question, Christine. Louis Pasteur invented a cure for smallpox. Is that science fact or science fiction?
I'm getting a shout from the kitchen that it's fact, but I thought he was the one who invented pasteurisation.
So what are you going to go for, fact or fiction?
Fiction.
You're correct. It was actually Edward Jenner who discovered how to use a relative of cowpox to vaccinate people against smallpox. So dead right.
Well done, Christine. 2 out of 2, on par and equal first place with Bob. Thank you for joining us on The Naked Scientists.
Thank you.
Stripping down science.
Okay, let's do it.
The Naked Scientists.
The Naked Scientists, Chris, Dave and Phil, into the last 5 or 6 minutes. Here's someone who reckons he knows what that voice is saying. Paul, hello.
Hello, how are you?
Very well, thank you. Right, listen to this. What's it saying?
It sounds like, to me, can you understand the word I spoke?
Not quite, I'm afraid, Paul, but a valiant effort all the same. Thanks very much for joining us.
Thank you.
Hazel's in Norfolk. She thinks it's saying sensitivity and speech, but she's not sure about the rest. OK, I think we're going to have to let everyone in on this one. Let's head back to King's School in Ely. Anna's waiting there with Wendy, Matt and Emily, and we're going to find out exactly what that voice really is saying. Anna, come on, let the cat out the bag. What is it?
Hello and welcome back to the King's School in Ely, where we're here with Wendy from Science Made Simple and our student helpers Matt and Emily. Now, what we've been doing is we've been listening to some very, very strange computer-generated voices and having absolutely no idea whatsoever what it's saying. So, what are we going to do now then, Wendy?
Well, before we reveal the answers, we'll just play it one last time to give people a last chance to sort of see if they can get any words, because I think Matt picked one up before, so we'll give Emily another chance to see if she can pick one up too.
OK, let's go. OK, well, that's still all Greek to me. So, Matt, can you reveal exactly what it says here?
Sound and music can be used for the synthesis of speech.
Sounded a bit different when Matt said it, actually.
It did indeed sound different. So can we see whether it actually said that? So it was sound and music can be used for the synthesis of speech.
OK, it's exactly the same clip again. I haven't tricked this at all. Here we go.
Emily, could you hear that this time?
Yes.
Are you sure? You don't look quite sure there.
Well, I could hear bits of it now. I know what it's saying.
Well, shall we listen to it one more time?
OK.
Sound and music can be used for the synthesis of speech.
So Matt actually picked up one of the words, so he got sound right. Let's try again.
Wow, that's absolutely amazing. I really can hear that. So, I mean, how did you even make that sentence in the first place using a computer voice? How does that all work?
Well, this is quite an early attempt at doing computer voice synthesis, but it's really quite hard to copy a human voice because every time you speak, you've got two elements of sounds going on. One is the pitch part, so effectively you're singing as you speak. So you could speak really high, or you could speak really low. So that's one part, so the computer has to generate that. And the second thing it has to do is generate these sounds which are like percussion, so they're called fricatives, things like pa, ka, ta, sa, and they're very hard sounds to form, if you like. Now, one of the problems with this voice is when you hear it, you'll hear it's all on one pitch, so it sounds very robotic, yeah? And so immediately you know it's not a real human being. And it's very hard to copy a human voice. It's almost as unique as your fingerprint. So the reason it's very hard to understand is you've only got one pitch, and it's also not very good at making those sort of sounds that you need.
But why is it that as soon as you showed us exactly what it was, showed us those words, sound and music can be used for the synthesis of speech, that then all of a sudden we could hear it?
Well, your brain's really powerful at sort of filling in the gaps. And obviously, if you suggest to someone what they're meant to be hearing, or what they should expect to hear, then when they see the words or hear them in their head and then hear the voice again, they can just put in all the gaps of the stuff that was missing before.
So is that kind of like when I'm listening to somebody in French and I only know a few French words, I can kind of fill in the gaps and kind of get what they're saying?
Yeah, I mean, you can put the sentence together effectively by the words that you're missing. And in fact, it's a little bit like the way people used to suggest they could hear hidden lyrics in songs played backwards. So, you know, if someone suggests to you that you can hear these certain words and then you listen to the song backwards, you're likely to hear them because you're expecting them.
And Matt, sorry, you had a question there.
No, I was just going to say it seemed really amazing that when we knew what it was saying, that it seemed so much clearer.
Yeah, I mean, that really was amazing. And now do you feel as though you understand exactly why that was, with our brains actually filling in the gaps?
Yeah.
And what did you think of the experiment then, Emily?
Quite weird.
And were you expecting it to actually say anything in the end?
No.
Well, I have to say, thanks very much, Wendy, for that. Computer voices and our brains being amazing and filling in the gaps. Well, that's it for this week. That's enough from the King's School in Ely. Thanks very much, Emily, Matt, Wendy. Did you enjoy yourself, Wendy?
Yeah, it was great, Tom.
Thanks very much. Well, we'll be back doing some more kitchen science next week, somewhere in the Eastern region. So, goodbye for now.
In fact, next week, we'll be finding out why it is that the sky's blue. Thank you very much to Anna, who's out there at King's School in Ely, and thank you to everyone who also had a go. One guy who reckoned he was so close, we decided that he's definitely going to be the winner. Matt's in Essex. Hello, Matt.
Hello.
What did you think it was?
The first time I couldn't make any sense, but the second time I thought it was sound waves can be used for the synthesis of speech.
So close. But it's interesting, now you've actually heard it, you can make sense of it easily, can't you?
Yeah.
Yeah, intriguing.
But
okay.
I used to have hearing problems, so
did you?
I listen more attentively now.
OK, well, thank you very much for joining us on The Naked Scientist. You won yourself an Encyclopaedia Britannica, so you'll have an enormous wealth of knowledge that you can share with us in the future.
Yeah, thanks very much.
Thank you very much, Matt.
Bye.
The Naked Scientist, Dr. Chris, Dr. Phil and Dr. Dave. We've got a couple of minutes left. I'm just going to sneak in a very quick one for you here, Phil, which is, this is from Chris Reynolds, who's in Mexborough, South Yorkshire, and he says, "Hi, Chris and team, I got an MP3 player for Christmas. I downloaded all your past shows and I listened to them at work. Great stuff. It's the best podcast on the internet. I have a question about meteors. If someone was to land on one, would they have to hold on like you would onto the outside of a car moving down the road, or would you even notice that you were moving, like we don't notice when we're standing on a planet, or would it depend on the size of the meteor and the gravity?" Keep up the great show, Chris.
Well, actually, yes, you would have to hold on, but not because it's moving, not like you're trying to hold on to a car, but actually because the gravity is so low on an asteroid. In fact, we've launched the Rosetta mission that's going to land on asteroid Churyumov-Gerasimenko, I think it's pronounced. We call it CG for short because it's a bit hard to pronounce. And that's actually going to have harpoons on it to lock itself onto the asteroid, otherwise it would just literally float away. So, absolutely, yeah, you've got to hold on.
This one is an email from Jitan Samani at ubs.com. It says, with reference to the last question about sending radio signals, if it takes huge dishes to send signals into space, how do things like Venus or Mars rovers send their signals back when they send us their data? You've got about 30 seconds on that one, Phil.
Well, the reason why we use huge dishes is because the space probes use small dishes, so they send very weak signals that are even weaker when they get here, so we have to use really big radar dishes to hear them.
Isn't the other thing that also the rover tends to beam information up to a sort of orbiting satellite, and that then beams it back onto us at a time when it's convenient to us to hear it?
Absolutely correct. And the Huygens mission did the same with Cassini. It beamed its data to the Cassini orbiter, and then that beamed the data back to us. So in like a relay sort of form.
OK, well, I think we've probably stuffed about as much into this programme as we possibly can this evening. It has been the Naked Scientist Science Question and Answer session. I have to say some very big thank yous here. I have to say thank you to Dave Ansell, who's normally our kitchen science guru, who came in to lend a physics arm to tonight's programme. Thank you very much, Dave.
Cheers.
Thank you to Phil Rosenberg from the Open University, who comes in and talks about space science for us. And our wonderful production team here and the BBC, Anna Lacey, who you heard there, who's out at King's School in Ely, also Petro Minch and Holly Barclay. Now, next week, we're going to be talking about something which is close to all of us' hearts here in the UK, which is the weather. How can we predict the weather, and how do weather forecasts actually work, and how far into the future can we accurately predict the weather? If you've got any questions on that, give me an email, chris@nakedscientist.com, and we'll see you next week.
Sorting out the sparks from the quarks. The Naked Scientists. For more information, get online at nakedscientists.com.